We're going to go ahead and continue the lecture with part 3. File-based I/O or input-output. Input-output is particularly error-prone because it involves interaction with the external environment. In other words, as you try to read files, they might not be there. You might try to create a file and you bump into a file that already exists. These types of things can actually happen and happen fairly often. There's actually code where you design it with the expectation that those errors are going to occur, and then you recover. So for example, you try to write to a file to discover that it's not there, so you go ahead and create it. The Java I/O package supports input-output. Java.io.exception. IO exception is a checked exception. Java.nio packages. So there's a bunch of different things out there that are helpful and worth going through. Java.io.file provides information about files and folders, directories, etc. That's a package. More specifically, Java.nio.file.path is a modern alternative. So you can use IO or NIO. It's up to you. Your shop may have a standard. Go ahead and work with it. File is a class. Path is an interface. Files and paths work together. Classes are in java.nio.file to work with. Not a whole lot here. As you work with files, you'll see more information. Readers, writers, and streams. So readers and writers deal with textual input based around the char type. Streams deal with binary data based around the byte type. So what's the difference? One is expecting a plain text file, and one is expecting to open up a file of any data type. They get sensitive around certain control characters, so as a result, I tend to go with streams versus readers, but that's up to you and what your need is. Address Book I/O project illustrates text I/O. The 3 stages of file output are open a file, write to the file, close the file. Failure at any point results in an I/O exception. Use FileWriter for text files. Okay? So it's just giving you some basic ideas and concepts of what to do and how to proceed. So here we do a try, FileWriter writer equal new FileWriter. That's the name of the file. While there's more to write, you keep on doing it and you keep this loop going, and then you close at the end. Something went wrong with the accessing the file. So there's some tuning that you might be able to do to this, because here the file is open. If an exception were to happen here, this close never occurs and you end up down here. So things to think about as you implement your try-catch blocks. Make sure that you always close out your files. People will put them in a finally clause, but then you need to make sure that it actually opened it in the first place. There's lots of ways to skin this cat. Make sure that you're talking with your shop and you're following your development standards within your organization. And I can provide more insight and guidance if you need to. Try with resource. Use for ensuring resources are closed after use. Removes need for explicit closure on both successful and failed control flows. Here's one approach. Also known as Automatic Resource Management, or ARM. So here, try. We're going ahead and doing all of this. Notice how this is up in the try block. Okay, that's slightly different. While, etc., doing more stuff, something went wrong, get out. So in other words, because this try is up here, it's actually sitting there going, because you're doing this, you must want to close it once you exit out of this try-catch block. So it will go ahead and take care of the closing for you. This is a very effective way of going. It makes your code a little bit harder to read at the top, but overall provides better resource management. The alternative is to have a try block and then a try within here with a finally. Okay? This is a more efficient, more expeditious way. Text from a file, text input from a file. Buffered reader for line-based input. Open a file, read from the file, close the file. Failure at any point results in an I/O exception. So this is for line-based input. It's going to read one line at a time from a file, a text file, and go from there. This is one of these that, at least for me, when I was learning this, I went through and Googled it and spent some time learning the additional stuff about this. because when you first start doing file I/O, it's always confusing as to which one you should use. Text input from file. Buffered reader creates a static new buffered reader method in the java.nio.file.files class. Requires charset from java.nio.charset. And then in here you have to be able to say what type of character set you're reading and go from there. So, character set is equal to US ASCII, which is the most common type you'll encounter. Paths get file, buffered reader. Now it's going to do it. Some comments just to show you that there's pseudocode here, catching the IOs and going from there. So remember, this is that ARM approach that we just talked about. Here are the two exceptions that occur, and we go from there. If you want, go through the tech support IO code base. If you want it, let me know. If you don't have access to it, I can always upload it. Text input from the terminal. System.in maps to the terminal. Terminal is, think of it as your keyboard or your command line prompt, or they do have a terminal in BlueJ that you can work from. Its type is java.io.input-stream. It's often wrapped in a java.util.scanner. If you think about the wrapping of what we've talked about, scanner with file is an alternative to buffer read. Excuse me. Parsing input. Scanner supports parsing of textual input, next int, next line, etc. So what this is going to do is, as it's going through, it's going to read these items for you. If you know what your input's going to look like, it's really helpful. If not, this may not be your best approach. Its constructor supports string, file, and path arguments. Again, go through it, get more information. There's a lot of documentation, a lot more information to look at. Spend the time going through here, get the information that you need, come to me with questions, review the book, look at the Java doc, look at Google, and you'll really expand your knowledge here. Input-output is an area where errors cannot be avoided. The environment in which a program is run is often outside the control of the programmer. Exceptions are typically checked in this case. Key classes for input, output are file reader, buffered reader, file writer, and scanner. It is worth your while to spend time with this, especially if you want to do more work in the Java world. Binary input involves stream classes. The path interface is an alternative to the file. And then try with resource simplifies closing. You've heard me mention it multiple times. If you don't do it that way, your closes and other things could get out there and cause resource issues, could cause files to become corrupt or not fully written to. With that, that's the end of the Chapter 14 lecture series. I hope you got something out of this. Thank you very much, and come to me as always with your questions.